Okay, so we are going to start off in Chapter 8, our last chapter in calculus, by talking about volumes and rotations. So in 8.1.1, we'll be talking about volumes by slicing. It says here that Simone has a part-time job working as a waitress in a fine restaurant. While she enjoys her job, her thoughts are frequently directed towards her goal of becoming an engineer. One day, she looks at the sliced limes that are placed on each water glass and realizes that the slices can be used to estimate the volume of an entire lime. She promptly slices up the lime, creating cross-sections. So what we're doing is we're taking limes, and we're going to be cutting them, and she's going to try and fill up the entire glass with limes that are completely against the sides. So what is the geometric term that best describes the shape of each cross-section? So if we think about a glass here like this, and we are trying to fill up a lime in here, what is this shape? And this shape, since a glass is a circle, we end up getting a cylinder. So this is a cylinder. Using a similar process, we're going to determine the volume of the lime that I provide to you. Yeah, I'm not going to give you a lime. So let's move on. Lime Lab Part 2. The volume of the lime in part 8.1 can be approximated with the volume of each slice. By adding up the volumes of successive slices, a Riemann sum is formed. Explain how the expression below represents this sum. This sum is the sum of a bunch of stuff. So what stuff are we adding together? We're going to be adding together every cylinder that's in each glass. So this is the sum of all of the slices from one slice to n numbers of slices. In order to get an exact volume, we're going to need an infinite number of slices. Can't give you that. Or as n approaches infinity. So we have this last problem here. It says, with a rare vase, Warren measures the diameter in centimeters every 5 centimeters up the vase. So we're going to make a total of 10 measurements, shown at the right. We're going to use this data to estimate the volume of the vase. So we know from the previous one, we're talking about a bunch of cylinders, and we're going to be adding a bunch of cylinders together. And the area of a cylinder is pi r squared times height. Let's go ahead and write down and find his volume. So the volume is going to be pi. This is 7. The diameter of this cylinder here is 7, so that means the radius is going to be half of that. So we're going to do 7 over 2 squared times our height, which is a 5. So each cylinder is going to have some radius. We're going to multiply it by the height, and our height here is going to be 5 each time. So we're going to multiply it by 5. And then we're going to add that to pi. The next diameter is 8.4 times 5. Pi, and then so on and so forth. And there's got to be an easier way to write this. So let's go ahead and combine things together. Like, what are some terms that we could factor out of each of these? Pi, I'll do the next one. 11 over 2 squared times 5, right? Notice that all of these terms have a pi, and they have a 5 in it, which means that I can factor them out of the expression. So in order to make this expression easier, we can rewrite the volume as 5 pi times, let's do bracket, 7 over 2 squared, 8.4 squared, or 8.4 cut in half, 11 over 2 squared, and then we have 15.3 over 2 squared, 18.1, 19, 18. If only there was a faster way to write down the sum of all of these things. We certainly don't know a method yet to be able to do this, do we? Alright, cool. Well, type all that in your calculator, and we'll get a sum. Oh look, I'm going to save you some time. It's 8,259.4 404 centimeters cubed. So that's going to be our volume of our vase, estimated with height of 5 centimeters. What if instead he did measurements every 2 centimeters? What would happen? We would end up having more slices, and as we get more slices, what would happen to the volume that we're estimating? Oh wow, our volume will become more accurate. So continuing this process, how would he go about determining the exact volume? Well, we would need an infinite number of slices. And your assignment is going to be those 4 problems. I will see you later.